This Turbine Otter is the workhorse of the floatplane fleet at Misty Fjords Air in Ketchikan, Alaska. The father-son team of company founder Dave Doyon and chief pilot Dave Jr. operate the 11-seat airplane on flight seeing, passenger, and cargo flights throughout Southeast Alaska. The Part 135 air charter firm took part in the FAA's pioneering Capstone program, which proved the safety enhancements of in-cockpit weather, traffic, and terrain warnings. It's a spectacular place to fly, and a treacherous one too. Rain and low visibility conditions are common, and coastal mountains rise several thousand feet from the ocean. But the 750 horsepower Otter seems at home here. It was made for these demanding conditions. This Otter has 11 seats, a glass-paneled Chelton avionics upgrade, and dual control yokes with levers easily reachable by left and right seat pilots. Chief pilot Dave Jr. has been flying and teaching in this airplane for years, and he knows its unique capabilities.
Okay, water rudders are up. Flow check is complete. Trims are set. We're going to go to high idle. We're going to push our torque up to 58.6. 2200 RPM is what we're looking for. That's going to give us 750 horse. I'm going to let the plane roll up on the step. And there it is. Airspeed's alive, quick cross check. And we're in the air. We're going to pull it back to 52,000. And the only thing holding us back at this point is flaps. So flaps will come up. Most of Havillands, you're going to leave some flaps down when you're climbing, but Otter basically climbs just fine without flaps.
How many degrees of flaps is that?
Basically about 40 degrees is
wow.
what takeoff is set for. All right, we're just going to level off here at about 800 feet, stay in our block altitude. Yeah, so we're about 56 gallons an hour right now is what we're burning. Yeah, the Otter doesn't climb, even with the turbine, you get 900 to 1,000 feet a minute out of it, on a good day, fully loaded. Compared to a Beaver at 500 feet a minute on a good day, that's it's a good improvement.
Which fuel tank are you on?
Well, it's always on the center tank no matter what.
Right.
The only way you can shut off the center tank is to either pull the condition lever or pull the emergency fuel shut off. Otherwise, it's always on. And
gotcha.
So your job as a pilot is to be managing your fuel throughout the flight. The book says start transferring at 60 gallons. A smart Otter pilot will always keep his center tank as full as possible in case you lose the ability to transfer, because that's what you have to get home
right.
on.
Dave Jr. describes the Otter as mostly docile, but it has a few characteristics that can get pilots in trouble.
So we're going to slow it up here. We'll go right to ground idle here. Get her in the flap range. There's about 75, 70 there. Put a little power in, we'll hold about 2,800 feet. These fly much slower, but just for demonstration here, we'll just kind of hold 70, and it's a real docile airplane. You have full controllability at these low speeds. I mean, there's very little tendency for it to fall off. Good responsiveness, so you can go around, and the maneuvering is great with the flaps in the takeoff setting at this power setting. You can really bring it around, and if you want to do an about face and turn out of a box canyon, being in this configuration, you can really swing this airplane around.
Yeah, I can see you're using very little real estate.
Yeah, very little real estate, and if you want to climb up and out of a small lake, for instance, you leave full flaps down and you pitch up, to about 70, and you can corkscrew up and out. So they say the Turbine Otter is the closest thing to a helicopter that is a fixed wing. So, you can comfortably come around, and I'm fighting, of course I'm fighting the torque going this
right.
way. You can comfortably just come around and just levitate up. All right, we'll just return to cruise configuration. The one characteristic about a STOL aircraft is the high stall speed and the clean configuration. So we have flaps up, we're totally clean. And when you crank it over, it's a little harder to simulate without a load because, normally at full gross weight, the stall speed's over 100. So in order to simulate it, you have to tighten it up a little bit.
Sure.
So when we come around, we're holding 3,000 feet, we're gonna put some G's on it. You can get that stall warning light to pop on, and you can start feeling the tail shaking. I can feel it in the rudder pedals now.
Yep.
I can feel that buffeting. So there's about a 60-degree bank with a couple of G's, and you can get them to stall in this configuration.
Right.
But fully loaded at gross weight,
Sure.
it'll happen. And the torque is so great that oftentimes it'll roll you inverted. So we generally don't take them to a full stall when we're doing maneuvers. It's just to the first indication.
Roger.
But they're very docile. When you do a full power on stalls in these planes, the tendency, once it breaks, it's pretty much snaps over and comes, straight down. The tail does stall. And but like we can pull it back to idle clean and just do a power off here. And with the Baron STOL kit, it's very docile. And you'll see the light pop on here in just a second. There it is. And it just pitches forward. Nothing dramatic.
Roger.
Maneuvers complete. It's time to head back to the main canal in downtown Ketchikan for a water landing.
Okay, on approach here, we're gonna slow it up a little bit. Looking out for boat traffic, boat waves being a big one here. When these boats are under full steam, they throw a pretty good, 4 to 6 footer out the back, some of them, and we don't want to land in that. The Otter will handle 3 footers fairly well, but much past that, you risk breaking things. So
Sure.
just getting the flaps all the way in, everything's forward, landing check's complete, eyes are outside. And now all I'm thinking about is going around if we need to. So I've picked a point out in front of me, the breakwater up there, the marker. We're well past this big swell. We'll just ease it on into ground effect here. Speed's good, we're at about 70 miles an hour right now. And we're just gonna find that flat pitch attitude. Still thinking about going around. Okay, we got landing assured. We're gonna touch down. We're gonna apply some reverse. And we're stopped in, 300 feet tops.
That's amazing.
68 Bravo's on. 160 Bravo, thank you.
We'll land in the turboprop, though. You never want to 100% trust that reverse is always going to be there. So you always give yourself that run out room that you would normally have just by touching down and pulling idle.
All right, well, thanks for the demo. Much appreciated.
Yeah, my pleasure. So we're just coming in for a docking here. Trying not to ever swing the prop over the dock, because we have people on the dock here.
Sure.
Don't want to wrinkle the float either, so we're going to come in and just kiss the tires real light. They're going to get a line. My goal is to get the dock line lined up with the forward strut. Once we get tied up, we're going to use it as a spring line. We can apply some reverse, and that's going to suck the plane in tight to the dock, so the dock people don't have to pull their backs out trying to wrestle this beast into position. We're waiting for 3 lines minimum. We're going to shut it down full feather this time. And there's a signal for feather. We got 3 lines on. I'm going to advance it forward. Okay, coming back to feather. We'll watch the oil pressure dump. Prop down to 300 RPMs. Okay, we're all stabilized at 52% now. And then condition lever off. And we're looking for an oil pressure warning, and we're going to look for a gen fail. This is a double check that both those systems are working. There it is. So we're good to go. And then we're going to let this spool down to 3% before we shut off our fuel boost pumps. That fuel pressure actually lubricates the FCU, so it's important to, because the engine's still spinning inside, even if the prop isn't, because it's a free turbine. There we go.
Dave Hirschman, AOPA pilot.